Good morning. This is the audio lecture for visually impaired students on the topic air pollution. The problem of air pollution is not a new one. It has been around for centuries, more than 3 centuries ago. John Evelyn, a noted scientist and diarist, compiled about severe air pollution around London. He described with great accuracy the effects of air pollution resulting from combustion of coal. Extensive studies in this context, however, have been carried out only during the last few decades. When we talk of pollution of air, we mean generally the pollution of that part of the atmosphere which is nearest to the Earth's surface, extending to a height of about 80 kilometers. This is known as homosphere since it is composed of a homogeneous mixture of various constituents. The homosphere consists about 99% of the total atmosphere air pollutants. The air in nature is never clear. It is invariably polluted. The common gaseous pollutants are CO, CO2, SO2, H2S, NO2, and common solid pollutants called particulates are carbon and dust particles, pollens, aerosols of lead, etc. The gaseous pollutants are released into the atmosphere as a result of volcanic activity, vegetation decay, forest fire, coal refuse fire, etc. natural activities, as well as by combustion of coal and oil, burning of gasoline in automobile, agriculture, and slash burning, etc. human activities. The particulates are produced by volcanic eruptions, high velocity winds, and biological processes, natural activities, as well as by smelting and mining operation, stone crushing and grinding, incomplete combustion, etc. human activities. In addition to the above common pollutants, some specific pollutants such as chlorine, hydrocarbon, chlorofluorocarbon, pesticide, etc. are also ejected into the atmosphere from specific industrial units and industrial processes. The various air pollutants and the sources from which they originate are given in table 1. Normally, carbon dioxide is not considered as an pollutant. We shall now discuss at the length the adverse effect of various pollutants, the maximum limits of their tolerance, and methods of their detection and control. Carbon monoxide, as mentioned above, carbon monoxide originates from incomplete combustion of carbonaceous matter in automobile engines and defective furnaces, incomplete combustion of agricultural and slash matter, and also by the interaction of carbon dioxide with coke at high temperature in industrial furnaces such as blast furnaces, some natural process such as forest fire, volcanic activities, seed germination, lightning discharge during thunderstorm, etc. also release carbon monoxide in small amount. Major proportion of the gas is of course contributed by human activity. Thus, of the total of CO present in the atmosphere, about 73% is contributed by vehicular exhaust and about 17% by forest fires and agriculture and slash burning. Industrial processes involved in the steel, paper, and petroleum industries contribute about 9.5% of carbon monoxide. The contribution by natural phenomena is thus very small. Although considerable amount of carbon monoxide is being emitted continuously by human activity, its concentration in the atmosphere does not increase to any significant extent. This is because some factors operate in nature which eliminate carbon monoxide. Recent searches have shown that soil is capable of removing large amount of carbon monoxide from the atmosphere by virtue of the action of some soil microorganisms. Technically, the element or organisms which consume a pollutant are known as a sink. Thus, soil microorganisms act as a sink for carbon monoxide. In thickly polluted urban areas, the concentration of carbon monoxide is considerably high because of heavy vehicular traffic and insufficient availability of soil to act as sink. On the countryside, the concentration of the gas is comparatively small. Toxic effects of carbon monoxide. The toxic effect of carbon monoxide on human beings and animals arise from its reversible combination with hemoglobin present in the red blood cells of the blood to form hemoglobin carbon monoxide. Normally, the hemoglobin of the blood combines with oxygen of the atmosphere present in the lungs to form oxyhemoglobin, which undergoes dissociation to release the oxygen to the body muscles. Thus, oxyhemoglobin acts as oxygen carrier for blood. Since hemoglobin has much greater affinity for carbon monoxide than for oxygen, hemoglobin with carbon monoxide inhibits its oxygen carrying capacity in the blood, thereby reducing the availability of oxygen for the blood cells, resulting in anoxia, oxygen starvation. Hemoglobin contains five coordinated iron atoms. The sixth coordination site of each of these iron atoms is unoccupied. The molecular oxygen present in the lung adds to the iron atom, though the sixth coordination site, and get detached easily at the cell of the muscle. If instead of oxygen the stronger carbon monoxide ligand occupies the sixth coordination site of the metal, hemoglobin would not be able to take up oxygen from the lungs and deliver it to the body cells. The maximum permissible concentration of carbon monoxide in the atmosphere is 40 ppm for an exposure of 8 hours. If the concentration is higher or the exposure is longer, adverse effect starts. There is some medical evidence that even as low a concentration as 10 parts per million of carbon monoxide in the atmosphere may produce increased mortality amongst hospitalized heart patients. The higher rate of heart disease in smoker is also believed to be due to carbon monoxide which the smoker inhales from the cigarette smoke. It has been estimated that a person who smokes a pack of cigarettes daily inhales smoke, which may raise the level of the blood hemoglobin carbon monoxide to about 5% or more. This result in impairment of mental performance, visual activity and other body functions. The most effective treatment for carbon monoxide poisoning is to confine the victim in a chamber having oxygen at 2 to 2.5 atmospheric pressure. This accelerates elimination of carbon monoxide from the hemoglobin. Exposure to oxygen under high pressure also correct anoxia by making available large amount of dissolved oxygen for blood directly, thus enabling the body to bypass the uptake of oxygen through hemoglobin. Carbon dioxide. Usually, carbon dioxide is not considered as an air pollutant. However, release of the vast quantities of the gas into the atmosphere by the combustion of fossil fuels, decomposition of carbonates, and biological decay are likely to bring about significant changes in climate. As we know, a large amount of heat is received by the earth from the sun. About 66% of this energy is absorbed by the earth and remaining 34% is reflected or scattered back into the space. There is a growing spectroscopic evidence that earth absorbs radiation mostly in the visible region and reflects or scatters radiation in the infrared region. Carbon dioxide permits or allowed to pass the short wavelength radiations via high ultraviolet and visible radiation but impedes the passage of long wavelength, i.e. the carbon dioxide present in the atmosphere thus acts as a barrier against the flow of heat from the earth to the atmosphere. This results in increase of temperature of earth's surface. This is known as the greenhouse effect because like the glass of the greenhouse, CO2 permits the passage of radiations of short wavelength and impedes the passage of radiations of long wavelength heat radiation. It has been calculated that with a doubling of carbon monoxide concentration, the temperature of Earth's surface increases by about 1.9 degrees Celsius. Such an increase would have considerable adverse effect on world's climate. It can cause melting of glaciers, flooding of coastal plains, changing of the biological activity of oceans, and altering the patterns of cropping, etc. Chlorine. In the absence of rigid precautions, chlorine is liable to expose into the atmosphere from the sites of industrial units manufacturing paper, plastic, dyes, chlorinated hydrocarbons, and other chlorochemicals. This is also a possibility of accidental leakage in storage tanks and pipelines. Chlorine has a sharp, irritating odor and is poisonous when inhaled in large quantity, the maximum allowable exposure being 1 ppm for 8 hours. Oxides of nitrogen, nitric acid rain. Although small amount of NO2 produced by microbiological process in the soil do not consist a serious pollution factor, yet significant amount of NO and NO2 are emitted to the atmosphere by human activity, which cause considerable pollution. The oxides are produced by the interaction of atmospheric nitrogen and oxygen when combustion of carbonaceous matter occurs at considerably high temperature exceeding 1100 degrees Celsius followed by fast cooling. Thus, considerable amount of nitrogen oxides are produced during combustion of coal, oil and natural gases in industrial units and of gasoline and diesel in automobile engines. These gases are removed from the atmosphere in the form of nitric acid through the following sets of reaction. Nitrogen oxide reacts with oxygen to form nitrogen dioxide. Nitrogen dioxide reacts with water and oxygen to give HNO3. Nitrogen dioxide plus ozone reacts to give NO3 plus O2. NO2 plus NO3 gives N2O5. N2O5 plus water reacts and gives 2 moles of HNO3. HNO3 formed as above comes down from the atmosphere in the form of nitric acid rain. These acid get converted into nitrate salts on coming in contact with bases such as ammonia, lime, etc. Acid rain may cause the pH of water to fall below 5.4. The water having pH below 5.4 may affect vegetation as well as freshwater fish. The acid rain may corrode building materials and metallic structures. Nitrogen oxide causes fading of textile dyes and distortion of cotton and nylon. Several sensitive plants get adversely affected by nitrogen oxide concentration as low as 1 part per million for a day or 0.35 parts per million for a few months. The affected plants start shedding their leaves and fruits. Inhaling of the nitrogen oxide by humans result in pulmonary edema and hemorrhage. Nitric oxide alone does not have any adverse effect on human at concentrations that occur on the atmosphere even in highly polluted areas. No doubt hemoglobin has extraordinary affinity for nitrogen oxide, about 1500 times its affinity for carbon monoxide, but luckily atmospheric nitrogen oxide is unable to enter the bloodstream to react with the hemoglobin. However, higher concentration of nitrogen oxide are otherwise dangerous because of the possibility of its oxidation to produce nitrogen dioxide, which is highly toxic. A concentration of even 100 ppm for a few minutes can be lethal to human and animals. An exposure to 5 parts per million concentration of nitrogen dioxide for a few minutes leads to adverse effect on the respiratory system. Long term exposure to even as low a concentration as 0 to 0.6 parts per million aggravates respiratory disease in humans. Exposure of monkeys to 15 to 50 ppm for 2 hours has been reported to damage their lungs, heart, livers, and kidneys. Sulfur oxides, sulfuric acid rain. The common oxide of sulfur emitted by pollution sources is sulfur dioxide. This is the most harmful gaseous pollutant released into the atmosphere through volcanic eruptions, which is a natural activity, and through combustion of sulfur bearing fuels such as coal and oil, which is a human activity. This pollutant is also produced during the roasting of sulfide ores such as iron pyrites FeS2, copper pyrites CuFeS2, copper glands Cu2S, zinc blend ZnS, galena PbS, etc. Human activity. About 66% of total SO2 is contributed by natural activity and the rest by human activity. Part of sulfur dioxide undergoes photolytic and catalytic oxidation to give SO3. Thus, SO2 present in the atmosphere is generally contaminated with SO3, although the amount of SO3 is not more than a fewer percent of SO2. The SO3 formed as above changes to H2SO4 in the presence of moisture. This acid comes down from the atmosphere in the form of sulfuric acid rain, just as nitrogen dioxide comes down in the form of nitric acid rain. Both sulfur dioxide and hydrogen sulfide are dangerous pollutants. Sulfur dioxide irritates the respiratory system of animals and humans. A concentration of 10 to 5 parts per million for full day or zero point 0.2 parts per million lasting for 3 to 4 days has been reported to damage the lungs and increase the rate of mortality. Elderly persons and patients with heart or lung disease are very severely affected by these pollutants. Sulfur dioxide and sulfuric acid are known to affect vegetation uh, adversely even at concentrations below 0 to 3 parts per million. High concentration even over short period cause leaf injuries such as narcotic blotching of broadleaf plants and grasses and brownish discoloration in the tips of pine needles. Lower concentration over long period days or weeks hampers the production of chlorophyll, which result in chronic leaf injury including loss of green color by plants. Sulfur oxide are liable to damage materials and property primarily through their conversion into highly corrosive hydrogen sulfide. Building materials such as limestone, marble, roof slate, and mortar undergo physical deterioration due to the corrosive action of SO2 and H2SO4. The corrosion of most metal, particularly iron, steel, zinc, and aluminum, is accelerated by atmosphere polluted by SO2. Fabrics such as cotton, nylon, and rayon, leather, and paper also undergo distortion and fading. The drying time, gloss, and even color of paint are affected by the presence of sulfur dioxide in the atmosphere. Thus, sulfuric acid rain is hazardous. Along with nitric acid rain, it adversely affects the agriculture, crop, forest, metallic, and marble structure, humans, and human artifacts. Sulfuric acid rain, however, reacts with ammonia emitted by biological process to form NH4 whole twice SO4, an effective chemical fertilizer. Marble structure, limestone, and geological surface of ammonia thus act as sinks for atmospheric sulfur oxide. Hydrogen sulfide. The main natural sources of hydrogen sulfide are volcanic activity and anaerobic biological decay of protein matter in stagnant water and swamps. Anaerobic reactions occurring in sewage, sludge, and sanitary landfills also produce H2S. Industrial units manufacturing pulp and paper, hydrofluoric acid by reacting fluorospar with H2SO4 etc. also generate considerable amount of H2S. Since H2S is readily oxidized to sulfur dioxide, the gases are present together in the atmosphere. H2S has an objectational able smell like the rotten eggs. Its presence in the atmosphere affects the white lead pigments and silverware due to inversion of lead and silver to black PbS and Ag2S respectively.